Let us now look at a problem on time, speed and distance where the distance is constant. Right? You know distance is equal to speed into time. Right? Now in such a case, what will be the relationship between speed and time? If let's say for example you had to cover 100 kilometers at a speed of 50 kilometers an hour, how much time will you take? Obviously 2 hours, right? But if instead of 50 you drive at 100 kilometers an hour, then you will take how much time? 1 hour. So what is happening here is that as the time or as the speed is increasing, the time, if you notice, is decreasing. As the speed increased from 50 to 100, the time decreased from 2 to 1. Right? Now in this case, how much is the speed increasing? From 50 to 100, it is 100%. Okay? And how much is the reduction which is caused in time? From 2 to 1, which is 50%. Right? So increase in speed by 50% reduces the time by 50%. Sorry, increase in speed by 100% reduces the time by 50%. Right? Or in other words, we say that the speed is inversely related to time, which means that any increase in speed will result in a reduction in time. Okay? Sorry. Let's come back to the question in hand. A man drove from city A to city B, city A to city B at 60 kilometers an hour. And reached there at 6 p.m. So he drove from this place to this place at 60 kilometers and reached there at 6 p.m. If he drove at 120 kilometers an hour, he would have reached by 3 p.m. But if he drove at 120 kilometers an hour, he will reach by 3 p.m. Right? So how much time will he save? He will save 3 hours. Right? Find the speed of the car at which he would reach there by 4 p.m. We need to find out, to reach at 4 p.m. what should be the speed of the car. Now, in these cases, as I told you, the distance is constant. So we need to play between speed and time. What is the increase in speed here? The speed is increased by from 60 to 120 or 100%. It has been doubled. Right? So if the speed is doubled, the time taken should actually be reduced. And how much? We saw here that it has to reduce by 50%. Right? And what do we know? We know that 50% of the time which is being reduced is how much? 3 hours. That's what we are told. That if he would have driven at 120 kilometers per hour, he would have reached by 3 hours. So 50% of the time is 3 hours. So how much is the time taken? Time taken should be 100%, which is how much? 3 divided by 50 into 100, or 6 hours. Right? So he took 6 hours. Right? Now 6 hours he reached there at 6 p.m. Okay? Now what was the speed? The speed was 60 kilometers. So the total distance is equal to how much? Speed into time. Speed is 60. Time is 6 hours. So 360 kilometers. Right? Now if the time is 6 hours, what is the starting time? It has to be 12 p.m. That's why it took 6 hours. And what is the time at which he has to reach now? He has to reach at 4 p.m. within 4 hours. So the time now is 4 hours. Distance is 360 kilometers. Time is 4 hours. What stops you from finding the speed? Speed is equal to distance upon time, or 360 upon 4, 90 kilometers an hour. right? So the speed of the car at which he would reach there by 4 p.m. is 90 kilometers an hour. This concept is pretty important. Just remember this, right? As you get more and more into practice mode for these type of questions, you will be able to solve them much more quickly. This was more on the concept side, so I was trying to take a little bit more time. Okay? The trick is identifying what's the constant in these type of questions.